So today we are going to talk about the final measure of spread that we discussed in this class, and we're going to discuss standard deviation, and then using standard deviation as we draw a normal distribution. And so let's go ahead and dive into what exactly that means. So a standard deviation is a measure of spread that shows the average of the distance between each data point and the mean of the data. And it is represented by the symbol. Looks like this. It is the lowercase Greek sigma is the symbol for standard deviation. Alright, so a normal distribution is a bell-shaped curve representing symmetric distribution of data. And it uses standard deviations to divide that data into pieces. So, so we're going to be using that here in just a minute. So let's start with here. We have 5 values that we're going to use to talk about finding standard deviation. So I'm going to go ahead and put those values in least to greatest order, just because it's a habit that we tend to do, just because we need it in that order so often. It's not necessary for this problem, but it's nice just to have things in order. Okay, so first off, we're going to find the standard deviation, and in order to do that, we first need to find the average or the mean of the data, because we're going to be looking for the distance that each data point is from the mean. Right, so we add these values together. So 39 plus 42 plus 45 plus 49 plus 61, all divided by 5, gives me a value of 47.2. Okay, then we're going to take and find the distance each value is from that average. So we start with 39 minus 47.2, which is a distance of negative 8.2. 42 minus 47.2 is a distance of negative 5.2. 45 minus 47.2 is a distance of negative 2.2. 49 minus 47.2 is a difference of 1.8. And 61 minus 47.2 is a difference of 13.8. So now we have the distance. We are going to square each of those values. So I'm going to take that negative 8.2 and I'm going to square it, and I get 67.24. I'm going to take the negative 5.2 and I'm going to square it, and I'm going to get 27.04. I'm going to take negative 2.2 and I'm going to square it, and I get 4.84. I take 1.8 and I square it, I get 3.24, and then I take 13.8 and I square it, and I get 190.44. Okay, then I need to average those values, because I'm looking for the average of the distance between the data points. So I'm going to add all of those together. So when I add those together, I have 67.24 plus 27.04 plus 4.84 plus 3.24 plus 190.44. I'm going to divide that again by 5, and I get, let's see, 292.8 divided by 5. I'm going to get 58.56. So the final and last step is to take the square root of that number to find excuse me, to find the standard deviation. So I'm going to take the square root of 58.56, and I get 7.6524 and so on. And so what that tells me is that the values are distributed an average of 7.65 points away from the mean of the data. Okay, now when data is distributed symmetrically, it's not always, we know sometimes it can be skewed left or right, but when data is distributed symmetrically, it follows what we call a normal distribution. And it can be represented by a bell-shaped curve that has some very specific characteristics. And we use the standard deviation to help divide that data equally. All right, so here's what we have. The bell-shaped curve starts with the average here. This is your average value. And remember, that's the symbol that we talk about from our calculator that tells us that it's an average. So you could put mean here, that would be fine. Then we start sorting the data by going one standard deviation to the right, and then another standard deviation to the right, and another standard deviation to the right. Okay, so in this example up here, if this were normally distributed and 7.65 were the standard deviation and the average of the numbers is 47.2, then 47.2 would be here, and 7.65 plus that would be a value of 54.85. So any numbers between 47.2 and 54.85 would fall in this area of the curve, and so on. Then you would add another 7.65, and the next set of numbers would go here, and so on. Okay. Same thing happens to the left. We go minus 1 standard deviation, minus 2, and minus 3 standard deviations. Okay. And so this breaks up the data rather evenly. So this is 34% of the data in just this one little section. This is also 34% of the data. Then this smaller section here is 13.5%. This one is also 13.5%. This little section over here is 2.35%. And over here is also 2.35%. And what that leaves us with is 0.15% outside of those 3 standard deviations, and 0.15% outside of the negative 3 standard deviations. So in total, from this negative 3 to positive 3 standard deviation, 99.7% of the data is included between 3 and negative 3 standard deviations of the average. Then 2 to negative 2 represents 95% of the data. And then from here to here is 68% of the data. And so in words, okay, I know it's sometimes easier to see it in the pictures, but approximately 68% of data is within 1 standard deviation. That means to the left or the right, 1 standard deviation of the average. So 68% of the numbers in a normal distribution will fall right here within 1 number. So if we were using the example of if it were a normal distribution, we would say that 68% of the data falls between, let's do the quick calculation, 47.2 minus 7.65, falls between the numbers 39.55 and 54.85, because that's 1 standard deviation away from the average. Okay, so that's what we're looking at here. Now, that means that approximately 95% of the data is within 2 standard deviations, and approximately 99.7% of the data is within 3 standard deviations. So that's standard deviation and a normal distribution, or a bell-shaped curve that represents a symmetric distribution of data.